As you see, it's time to speak a little about various kinds of casting. But at first, what's casting? Casting is the technology of forming liquid metal to the desired solid shape with its special metallurgical and mechanical properties, shape, surface, grades, and etc. But what's the way to do so? Now we have a high temperature liquid metal, and it's obvious we must pour it in the heat resistant field. Sand is a simple material with heat resistant properties, but not every sand, a sand with special additives. Then you make the shape in the mass of sand and pour the liquid in it. Wait, it's solidified and you have your own shape. It's a good way to produce engine block, cylinder head, but with low plasticity and a low production rate. Low production rate. What's the solution? Produce more shape in a time. Design a tree with trunk made of fusible material like wax. Then cover it with thick refractory. Burn the wax and empty the mold. Fill the tree with liquid material. Then pick the fruits. This method wants high attention and money to produce high accuracy turbine blades. Previous ways, molds are temporary. It means that you must build it at the beginning and destroy it at the end. Let's go to use permanent mold that build of metal. The basic way to cast with permanent mold is to fill it with liquid metal and let the gravity to fill it completely. Solidify fast, 15% better mechanical properties than sand casting, large scale production, and use ferrous and non-ferrous alloys can cast. Gravity pressure may be low to fill the mold, so use a cylinder to increase the pressure and fill the mold under high pressure, solidify under pressure. Good quality but low plasticity limit the segment to use under impact pressure and vibrate. Extract the gas in the die-cast mold so dissolved gases and pures come out from the liquid metal and it gets pure. The mechanical properties and surface qualities improve significantly. You can cast thinner films, but control this metal is so hard. Remember that gravity method, but this time don't let gravity do the work. Put pressure on it and squeeze and let it solidify under pressure. It's good for aluminum, zinc, copper, and had a good surface, less crack and shrinkage. Imagine a glass of drink with solid particles in it. To drink pure and avoid surface particles, it's good to use a straw. In this method, something like a straw go in the middle of the liquid metal and surface low pressure forced liquid to go up in the mold. It has a good surface quality and clear outline. This method utilization is about 98%. Pour some liquid metal in a tubular mold, then rotate it. The liquid metal go to the inner surface of mold and solidify. Less metal loss, so good yield and fewer defect and slag inclusion, but no control on the inner surface of mold. It's good for engine cylinder and shaft sleeves. Loss foam casting is the next way, similar to the investment casting in general and different in detail. We use foam instead of wax coated with refractory in professional steps, then fill it with liquid metal under negative pressure to vaporize the foam, and finish. Reduce cost, clean production, flexible design, and grade are the benefits. Last method is continuous casting, an advanced method that you pour the liquid metal in a mold and pull out the solidified liquid from the other end of the mold would yield uniform structure, so good mechanical properties. You can cast steel, aluminum, copper, and magnesium alloys. This method produces long shape like rods, pipes, and slabs